an equation whose unknown is a function, not a scalar, not a solution set, but a function. Now, we're going to do some work here that's going to show you, that's going to simplify the process slightly here, or actually quite a bit. Notice right here that when you compose this quotient with itself, that is, you input it into itself, you get some very favorable cancellation right here. These 15s cancel, we get a 14x in the numerator, right here. And then downstairs, again, some favorable cancellation. The 3x's cancel, so we get 14x over 14, which is just equal to x. Now, another way of putting this, even though it's not really necessary to say it directly, is that this function is its own inverse. Okay, if you compose this function 3x plus 5 over x minus 3 with itself, you get x back, so that makes it its own inverse. Okay, now that turns out to be quite useful right here because it gives us the capacity to use this given, do a substitution, then employ kind of a elimination strategy. So that's exactly what we do. We substitute this 3x plus 5 over x minus 3 into the original, all right? Now notice again, this is just, you can just see it. If you put 3x plus 5 over x minus 3 right there, you get this, right? Okay, now we've seen that this term right here, 3x plus 5, when you substitute a 3x plus 5 over x minus 3 here and here, which is what we just did here, we get x back. So that's why this whole glob of stuff, this quotient right here, became an x, right? Now look here, x gets replaced with 3x plus 5 over x minus 3. You may say, what good does that do? Well, you see, it gives us the capacity to eliminate. Notice if we multiply this entire equation by 2, that'll just turn this into the additive inverse of this, and we can eliminate this chunk of stuff here. Okay, so that's exactly what happens on this very next line. Multiplying by 2 and adding. Y'all and I can talk you through it all day long, or you can just see what's going on. The whole goal was to eliminate f of the quotient 3x plus 5 over x minus 3, and that's exactly what happens on this very next line. Hopefully the instructions are clear enough now, or the steps at least. Now notice that this step right here, going from here to the very next line, notice, and this is just some standard algebra here, x times x minus 3 okay, over x minus 3 is what we have going on right here, right? Or I'm just trying to show you guys probably don't need to see this, but this is just equal to x, right? As long as x is not equal to 3. Okay, so you can see where the x squared minus 3x came from right here. Or this is just a standard common denominator idea. You multiply through by 1 in a clever way to combine this pair of terms into a single fraction. Okay, now notice here you get 6x minus 3x is 3x. And so on the very next line, we're in really great shape right here. Okay, let's see, what do we got? Yeah, okay. Now, and y'all, you see what happened? All of this eliminated the clumsy looking term, and we got f of x isolated. All right, we got f of x isolated. Multiplying through by the reciprocal, we see that this is the solution right here. Okay. It's a strange looking object in it, but it is a function, and it's the solution. Now, you may ask, well, how do you really know? How do you know you didn't make any mistakes? Well, you don't really know. But what we can do is actually check right here. What I did is I just arbitrarily checked for x equals 4. Notice x equals 4 is in the domain of the function. The only thing that's not in the domain is x equals 3. So we did a check here. This will be a check. For x equals 4. Now, y'all, this does not prove it conclusively, but it gives you some strong confidence that it's probably correct. So you guys can check out all the arithmetic here, but notice that I color-coded this thing for your viewing pleasure. So there's a 4 right here, a 4 right here, a 4 right here, And all the arithmetic craps out into a 4 right here, which is exactly this form, right? You know, x, 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 x. Now we, for a concrete example, arithmetically, 4, 4, 4, and 4. So that works out nicely there. Now, again, this isn't a proof, but it's, you know, it gives you some confidence, as I mentioned. And also, if you want to, you can go through and do this, actually show that this is actually equal to x, okay? Now, there's quite a bit of algebra going on here. This would be a good algebraic identity, just independent question all by itself. But if you go through the algebra right here, you will get that this is equal to x. And it's kind of a miracle. This entire mass of stuff actually just craps out to x. And notice that this is exactly in this form here. Or, sorry, yeah, in both cases, I just simplified it a little bit here, and I didn't continue. But, and again, you know, I'm not saying I know. The algebra is a pain. It's a pain. But if you take the time to do the algebra right here, all of this does collapse into x. And that indeed, that will verify that this is our solution to the functional equation, which was this. Okay, hope you enjoyed.